Hello. This is the second in a series of presentations about the OpenDSA eTextbook project. The title of our class is Integrating the eTextbook, Truly Interactive Textbooks for Computer Science Education. And today we're going to be talking about instructor tools and classroom use for the system. This course is presented as part of C2Gen, a Chautauqua for the 21st century. So let's get started. So what I want to begin with is a description of instructors tools that are part of the OpenDSA system, except I have to provide a big caveat that we are going to be changing a lot of this in the very near future. By January 2016, we should have a new system in place that takes advantages of learning management systems like Canvas. But in the meantime, this is how instructors have so far been using the system. Basically, we create a book instance for a given course, and I'll talk a little bit in a few minutes about how that's done. There are a couple of things that instructors can do with the book instance, and one is create assignments and another is track student progress. Let me show you some examples. So creating assignments, you go to a page at opendsa.cs.vt.edu is the server that most instructors are using. This page shows what the instructor will see once they've selected a particular course that corresponds to the textbook instance that they're using. And in this example, the instructor has created a number of assignments. An assignment is simply a collection of exercises from the book, and there's a button here that lets you edit the assignment. When you are editing the assignment, you can select from drop-down menus the particular exercises that you'll be using. This image here shows how to set information about the assignment. You can set the number of points that are involved. You can set due date, closing date, something about the submission penalty. This is the control panel for adding the various exercises. So if you want to add another exercise, you pick the chapter that is in there, and then there'll be a listing of the exercises under that chapter, and you just click on them and they get added to the list. And finally, the other part of the instructor tools is a fairly standard spreadsheet that shows for there's a row for each student and then a column for each of the exercises, summary information about various assignments, total for the student, so you can see exactly how much they've done. You can tell whether some have been turned in after the assignment due date and so on. In next year, all of these support features will be part of standard LMS like Canvas. All right. So the next topic I will be talking about is how one configures a book instance. A given course will have a book instance, and that book instance will have the textbook, the modules that you selected, and there's a number of things that you can choose to set up when you create a book instance. First, you can pick the language you want. Given that someone has done translations, you can pick the written language, whether it's English or Finnish or some other language. There's no magic here. Someone has to have done the translations, and we have translations for a few modules, and we're always looking for volunteers to do translations for more. The other thing you can pick is the programming language. We have code in Java without generics, Java with generics. Processing, which is a very minor variant on Java, simplifies a couple of things, and some C++ code as well. And so you can pick one or more of those. And in the first presentation, I showed examples of the code displays that could show off having one or more of these languages available. Visualizations will only show one version of any given code display. It'll always be the first one, the priority one that was selected in the configuration. Of course, you can select the modules and you can select how they will be broken into chapters. You can configure exercises in various ways, and you can also, in some cases, some modules have explicit section parts that can be included or not included. So all of this is controlled by use of a configuration file. So we'll take a look at an example here. This is the configuration file for the book instance that's being used for this series of presentations. So when you see the web page that I've been using to prompt my narration, that is a book instance. It was created using one of these configuration files, and if you go to the OpenDSA GitHub repository and look in the config directory, you can see examples of different configuration files. If you went through the guided tour, you may have recalled that the code examples had several tabs, and this defines the different languages. Since this is sort of a demonstration, I'm showing off a number of different programming languages. That's all controlled here. If I only wanted to show Java with generics to my students, then I would select just this one, and so on. The language I want is English, so I control that here. For any book instance, there is the book contents, and then there's the scoring server that captures the student data, and that is defined here where that scoring server will be. And a couple of sort of global options. If you want details, you can read the documentation about it. And then we get into the part that defines the chapter breakdown and the modules that are part of them and the exercises that are part of the modules. So if you looked at the table of contents for this book instance, you'll see there's an introduction chapter, and then there's a first presentation, which is this guided tour, and that has a series of modules: an introduction, the actual presentation page, which has on it various visualizations, and actual interactive exercises are all called exercises for the purpose of configuration. There are a number of parameters that you can set: how many points a given exercise is worth, some configuring of how many you have to get right, or what percentage of the exercise you have to get right to get those points, and so on. Here is another module page. Then we start a few more module pages, and we start down here the next chapter, which corresponds to the second presentation, which is what we're doing right now. And this has a few simple modules without any visualizations or anything on them, so there's no definition for that, and so on. So again, all of the details for what goes into a configuration file is in the OpenDSA documentation. Now I'll say just a little bit about using OpenDSA in the classroom and our experience. Many of the people working on this project are at Virginia Tech, and so a lot of the use has been at Virginia Tech, and in particular we've been using this consistently in our data structures course since fall 2012. We've also been using it in a standard CS2 course, the data structures component. So that was through most of 2014 and 2015 has been used, and you can see we've had a few hundred students each semester using this. And we've also been branching out some of the content. So we had a senior and a graduate algorithms course that used it last semester. There was about 60 students between those two courses. So those are users at Virginia Tech. We've also had users at a number of other universities in the United States and in other countries. So here's a listing of many of the other universities that have used it. We've had, again, hundreds of students at these different universities. And the last thing I want to talk about today is log data collection. So we log all user interactions, all mouse clicks, pages visited, timestamps for all of the interactions. And from that we can deduce various things like whether exercises are completed, whether all the slides and the visualization were viewed, what the timestamp for when the student looked at the module, when they started looking at it, when they went to another module, and so on. There's a lot we can learn from this. Some basic things are trying to deduce whether a given exercise is effective or not. So we can look at the time spent on exercise, we can look to see whether students voluntarily used it for study, we can look to see whether there's a lot of submissions that are successful or not, and what that ratio is, and whether it's a reasonable amount. So there's a lot to be learned from that sense. We also learn about system behavior and how students interact with the system. We, in particular, can tell that certain details about how the system is set up may not be optimal for learning, and students may be gaming something or they may be skipping it. By gaming it, I mean things like they may learn how to get around doing certain exercises. You'll find that most exercises, they don't particularly try to do that, but certain ones may be difficult and they may try to avoid doing them. Depending on, of course, how you choose to use it in the class, that may or may not affect grades. We tend to advocate a mastery approach where students are getting credit for completion, and the expectation is that all students will complete. And so the ones who actually put the effort in and use it for learning will then presumably know the material better and do better, as those who game the system getting a better grade than their peers is something we want to avoid. From detailed study of exactly how they use the system, we can then learn things that'll help us improve the system. Right. We can also find things about their time distribution. We can see whether OpenDSA is being used for them to study. So let me give some examples of things that we've learned from this. So there's a number of elements to a system that we call gamification feedback, in the sense that they're borrowing from standard features that you might see in games, mostly related to progress. Good examples of that are the check marks by the visualizations, module complete marks at the top of the module. When you look at the gradebook, whether the various lines are overlaid in green because they've been completed. So most of these are related to progress that they've made. And so we combine both log data and much surveying of our students to try and find out, on the one hand, from the surveys what their preferences are, and from the log data what's actually happening. So from the surveys, we see that on a 5-point Likert scale that they very much are in favor of these progress bars and so on. Now, we've also done various types of behavior studies, and we have found that while students report that they like these features, there's reason to believe they don't help their learning any. I did mention that some exercises are gamed. One way that students can game certain types of exercises, particularly if you have a static multiple choice question, by which I mean it's just a multiple choice question with some text and some various choices to pick from. And basically, once you've learned the answer to that, you know the answer. The question doesn't change. Different questions are given at random. If that same question were to come up again later on, if you've memorized the answer, you know the answer. So you can look for hints for a question, and if you use the hint system, you don't get credit for that question. But we see that for certain types of questions, students may look at the hints in order to learn the answer and then remember that for later. Part of the moral is that static multiple choice questions should be a rather minimal part of any sort of grading system when you have an online interactive education system. All right, we have looking at basic behavioral patterns, like on the exercises, do students look at the model answers? Some they do a lot, others they don't look at very much. It pretty well correlates to the more difficult exercises are more likely to have views of the model answer than not. Some sort of things that you would expect. That may help you to understand which ones the students consider to be difficult and which ones they consider to be easy. Some important things that we've learned from detailed analysis of behavior is that students tend to spend time watching visualizations of how an algorithm behaves. If you have sections of material about the analysis of an algorithm, particularly if that material is presented as standard text and images like in a textbook, they'll skip right over it. Even if they know they're supposed to learn that, they have a hard time for whatever reason actually spending the time looking at it. So this is driving us to do a heavy change on how we present that type of material. Unfortunately, there's not much experience in the user development community on how to create visual presentations of analysis material, but this is something we're working on very hard to create. Another thing we can learn from our logs is when students do various interactions, and whether that could be just any user interaction or completing exercises. You can slice that in different ways. It tends to be the same no matter how you look at it in terms of all interactions or viewing visualizations or doing exercises. These things all tend to be correlated together. What we can do is compare that to the time. And so, as you can imagine, there are various peak times, and of course homework due dates lead to peak use of the system with a very heavy drop-off after. But notice there's another peak here, and that it corresponds to the midterm exam. And what you should notice here is that, yes, there was a lot of use when the exercises were due for homework credit. After that, there was again a peak of use, maybe not so high, but a definite peak in use for what can only be interpreted as voluntary use of the materials for studying. And that pattern repeats itself here. There's a series of homework exercises or homework assignments, and you can see when the assignments are due, there's heavy peaks. But then at exam time, there again is another peak in use, and all of this is voluntary. These may have been assigned credit for the class. There's no credit for studying other than implied credit by better performance on the exam, and you get some sense of students using this system to study for the exam. Other types of studies that we do, some based on instructor surveys, some based on student surveys, and some based on looking at the log data. Types of data that we collect is where do students spend their time and how does that relate to how much time instructors think they need to spend on that material. A good example is recursion, topic of recursion. First, in a typical CS2 course, students may be encountering that for the first time. And from instructor surveys, we have an estimate of how much time they should be spending on it out of class. And from student surveys, we have an estimate of how much time they do spend on it, which is far less with traditional materials. And then after creating OpenDSA tutorials for recursion, we were able to both collect log data on how much time they spent and compare that to survey data of how much time they estimated they spent. Turns out that the time they really spent is pretty closely mirrored by the time they estimated that they spent. So that's helpful to have that information be consistent across those two different ways of collecting the data. And we found that with the tutorials, they didn't spend as much time as the instructors said they should, but certainly more than they'd been spending with traditional materials. We can also learn things like for key topics, say recursion or pointer manipulation, we can find out from instructors what the key topics are, and then we can develop concept inventories to see whether students are exhibiting certain misconceptions, and in the future we can hope to use that for sort of intelligent tutoring to adapt based on their feedback on how much they're doing the exercises correctly. Well, thank you. That's the end of today's presentation.